This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seberg. Good morning, Robert. How are you doing?
I'm fine, thank you, Peter. We have a very interesting episode today, a lot of research and science topics. Do you want to start?
Oh, yes, I can. You just mentioned the weekend was full of coronation.
Yes.
I heard it here or there. It's actually it's the second topic. I'm going to talk about an interview by The Guardian, and I was thinking, because I think they published it maybe yesterday. Yesterday would have been Sunday, maybe it was Saturday. I'll come to that in a moment. The first topic I have is a course actually by Andrew Wang. You know him, Deep Learning AI. And he did a course together with Isa. I think her name is Isabel. I was looking for her on LinkedIn. Fulford, she's from OpenAI. And together they do a ChatGPT prompt engineering for developers. So I started it, although I'm not a developer, and I'll come to that in a moment. And I didn't finish it, but I think I got the gist of it. And what I want to do is share just 2-3 prompting principles, tactics. They use the OpenAI GPT 3.5 turbo model, and as I was reading through my notes just a minute ago, and you suggested we're going to talk about, all these large language and smaller and open source and all of them later on. It's your topic. You can't really follow it anymore. It's a huge thing. And the more important that all of you, dear listeners, I really believe all of you, that's what I'm going to finish this piece with. So I'll share with you 2-3. So number one, they say, write clear and specific instructions. They say use delimiters. They say the longer the prompts are, the more clarity and context you provide to the model, will typically lead to more detailed, relevant outputs. You can ask for a structured output. You can ask the model to check whether conditions are satisfied. Not sure I'm going to share this one, but there was one even you can ask the model if the answer it was maybe giving in the first stage is correct. Mm-hmm. That's very interesting. So number 2, give the model time to think is what they say. Specify the steps required to complete a task, or instruct a model to work out its own solution, before rushing to a conclusion. And I must say, reading through these at the very moment, I think they're almost dealing with the model like, what should I say? Almost as if it was a human, right? Nevertheless, so ChatGPT prompt engineering for developers. I believe personally it's not only for developers. It's free for a limited time, they say. So I really suggest all of you listeners to look into it. You developers, you will finish it. I assume, you will do other ones. Maybe you've done it already. And you decision makers or you domain expert, you may finish it. But like me, maybe after 15 or 10 minutes. That's not the point. Look at a couple of these things. Don't go into the Python code if you don't want to. That's not necessary, but you will get an idea of how these large language models work. And then just as a finish, there was a second message from Andrew, and that's on visual prompting. So now we just talked about text prompting. Yep. So in the traditional machine learning workflow, all of you know that, are in this business or want to go into this business, you need to collect and label a training set, right? And that can take days or weeks, And in this prompt-based machine learning workflow, where the imagery is going to take over, you just highlight an area and, it's going to take a couple of seconds.
Wow.
Now, what I thought of, by the way, when I saw that, I thought, wasn't there this demo, and maybe you recalled it as well from Google.
Yes.
It doesn't matter who, but Google has been really good on doing a lot of stuff. It's just a topic in itself, almost like, they have done all this base work and then suddenly somebody else seems to run away. But they did this demo years ago. You would make pictures of your face on your notebook. You would make pictures of your, cup of tea. Yeah. And after 1 minute, the model would recognize your face. Or I think there is, some similarity between the two. I'm not going to say that what Andrew is suggesting is not good. Who would I to dare doing that? So I suggest also here, all of you have a look at it. We'll make the links available. Make yourself knowledgeable on how these large language models work.
Is it for free from Andrew?
I believe so, yeah. Maybe it's the same. I can't confirm. I believe so. I think it's a kind of positioning of his landing AI, right? Which we should stay close to. And I'm very, very interested in hearing from you listeners from the industrial community that have maybe experience, have a look at what it is that he is doing. If it is, structurally new, or if some of you are saying, well, we've been doing this before. Yeah, I cannot comment on that yet. And if, typically he's giving this for free for the moment, as a way to get people in, and then later on, if you say, oh, this is really good, I want to use this, then maybe you get to the next level of subscription.
It's interesting because in the main part, I discuss the topic transformers and Hopfield networks and large language models with Günter from JKU Linz. Very interesting. And his opinion on transformers and the future of transformers. Yeah.
I'm really, really looking forward to it. I haven't heard it yet because, and as you suggest, there was a comment from his colleague Sepp, right? Yeah. Because he was, weren't they both on? I think one of them was on radio, the other one on Austrian, and the other one on TV. Yeah. And even on TV, Sepp was already suggesting that something was in the making around LSTM. So I'm not sure that we're going to hear comments, but I'm very much looking forward to it.
I want to add something to large language models and ChatGPT. I want to add some industrial feeling to this because Eric Barnstedt posted a very interesting link. ChatGPT generates industrial asset definitions and enables automatic mapping to OPC UA. You already recorded an episode on this topic, right?
I did so last week, actually. It's in the making. Well, what we did, because you and I, we do also another podcast for OPC Foundation. OPC as the industrial data exchange architecture. I'm not going to go into the details. If you're interested in that, have a look.
Highly recommend it.
Yeah, and I did talk to Sebastian Kebisch from Siemens, and he did a presentation at Hannover Messe a couple of weeks back. And that there will be an overlap, I believe, between what he's been doing and what Eric. I haven't looked into the details of Eric yet. Eric is going to come to the podcast in a couple of weeks as well. But basically, it's like I can say as much as that, if certain people and the majority believe that, yes, I mean, as an example, OPC UA is a very, very powerful architecture,
Absolutely.
But it's sometimes cumbersome and not easy and difficult, then we can now all understand. I believe that's what Eric is saying, talking about as well. Use ChatGPT and it will do the work for you. Now that's a big quote that I'm putting Eric in his mouth. Eric, if that's not the case, come back to me. But that's, I believe it's going to be the same thing. We're now seeing all these examples of where things are complex. Ask ChatGPT to do it for you, kind of thing. And I'm not saying that works within 2 seconds. I'm saying it's a tool, but maybe instead of using an hour, maybe after 5 minutes and looking at it, what ChatGPT is doing for you. Okay, there's a small error, and then, as we just said, do the prompt engineering to correct it. It's amazing times we're living in.
Yeah, absolutely. And should I go on?
Please do.
Yeah, I was in Paderborn. Did you ever heard about Paderborn?
I was there as well, Nixdorf, right?
Yeah, it's Nixdorf. Yeah, it's the home of Nixdorf. Absolutely.
What is Nixdorf, by the way, for those of our listeners that have not heard?
Yeah.
Was he an early inventor of IT technology?
Yeah. He's one of the most important influencers or inventors of IT technology in Germany or in Europe, I would say. Yeah. I was at the robotics summit, and the focus was on robotics in surgery. And that's not our main part, but I recorded some episode for our robotics podcast. Mm-hmm. And I am not a doctor, but I brought 2 ideas with me, which really impressed myself. There was an idea using a SLAM algorithm. We already had an episode about SLAM.
Right.
In the kidney for navigation. That's crazy, right?
In the kidney, around in the kidney.
In the kidney.
So remind me, SLAM is for the robot to first, number one, realize where it is.
Yeah, right? and draw a map in the same time.
Right, where am I? Draw a map. So then it's saying, okay, where in the kidney am I?
And I will draw a model or a map of the kidney. Right.
Okay, and then we can think further and say, okay, and then the algorithms will say, okay, this kidney is sound, or this kidney has a problem in whatever coordinates.
Yeah, that was the first one, and the second one was, and what many do not know, robots work in the surgery, but not automated or partially automated. That's really interesting. So it's not really automated, but a guy from the Deutsches Zentrum für Luft- und Raumfahrt, DLR, is working on systems where surgery models are created based on the data that be used. And we know this from TRUMPF. That's the idea. So in quotation marks, the world knowledge for the machine tool. And yeah, we have the same in surgery. That's very interesting. They want to build a surgery model of one surgery, and then you can use this model for different patients and for different use cases. That's very, very interesting. Yeah.
I wrote about it in the book actually a couple of years back, one of the 100 questions I recall. And it was just because I did my final 1.5 hours last week kind of public presentation. And I quickly looked into this as well. I recall, number one, surgeons getting older, let's say, towards, 60s, 70s, and maybe their hand is not as stable anymore. I recall that was one. So there's still the surgeon, there's still the human, there's still the number one person to make the decision, not the machine. But by putting a robot in between, at the end, where the work takes place, there will be, a very, very stable machine doing the work, operated by the person. That's number one. And number two, of course, anything that is computer vision around, right? I recall quoting, and that was a radiology, but it's, of course, that is then radiology or whatever computer imagery around what I see in the body. And the person was saying, it is as if I have a second doctor, a second radiologist, a second surgeon standing next to me. And he or she, the AI is making suggestions, look here, look there. It's amazing what's happening there.
Yeah. Who is interested, we will have the full story in our robotics podcast in a few weeks. So I was very impressed because I'm not in this surgery medical thing,
right?
But very impressive what they are doing there. And there's a lot of combinations or similar, it's a little bit similar to the industrial sector because you want to have to You want to act modular, you want to use this robot as a cobot, you want to have data. That's all the same that we see in the industrial sector.
Completely agree. And I must say that I always feel a little bit weird when I have been saying for years that, everything is growing together. We have all these markets, and markets stay markets. And, marketing and product marketing, people like dissecting, making sub-markets and sub-markets because they can become then the number one in sub-markets. But that will probably continue to be like that. But from a perspective of what is happening in our, data world, data is driving all of these markets, and at a very high level, being, put 180% upwards down by AI. And exactly as you say, and if then you're going to make these comparisons between, as you just did, then I always feel like, and we are comparing, the working of the human body with machines, predictive maintenance. It's like fitness, right? Yeah. The fitness, on our arms, if we have them or not, they are like predictive maintenance in the machines. If we're repairing, or if an AI is recognizing somewhere, there's a problem in XYZ, and you just suggested, now looking in the kidney, I always felt a little bit weird. We have this total respect for the human being, the body and the mind, and then we're making this comparison with machines, right?
We have this ethic discussion, and we have one more discussion we have also in the industry. do we have the process to use this technology? Do we have the people to handle this technology? And for example, when you want to become a doctor at university, robotics and AI is not on the curriculum. So you can go there and listen to. There is a presentation, there is a tutor, but it's not. You do not need to go there.
Okay.
And that's a big problem, I think, because robotics and AI is coming. And also, when you want to become a doctor, you should know a bit of robotics in surgery and AI in surgery. Yeah.
We can only imagine that that's going to change, right?
Yeah, I mean, absolutely.
If not in a proactive, then in a passive way. I mean, it's going to be the same like everywhere. I mean, I think the general saying, like, whatever job X, including open for AI, is going to push away, is going to make the people X without AI obsolete, right? And that's going to be the same for universities. The curriculums who are not going to be proactive and include artificial intelligence and or robotics into their curriculum, at some point in time, the students coming away from those are going to say, why did the other person have all this training on AI and robotics? So I think we're going to see this change.
Yeah. You have one more news from Great Britain. Huh?
Well, that's where it came from, because actually, the father of AI, that's how he has been called, Jürgen Schmidhuber. He was then
what is the difference between the father and the godfather? Because there was a big discussion on Twitter.
At that as well. Yeah. The father, it's like, and the reason that Jürgen Schmidhuber was called, actually, there was a New York Times article in 2016. That's what the Guardian says, and they said, I don't know who wrote it, when AI matures, it might call Schmidhuber dad. Dad, as as you are a dad of your children, and I'm the dad of my children. That's father. And the godfather is more like, if you think, The Godfather is a famous movie.
Yeah.
And it's about, what is it? Can we call it, is it not Italian? Is it
mafia.
It New York? What mafia? It's mafia.
Yeah.
So it can, that's typically, but it might be a positive, example as well. But that's the person on the top, who is then typically maybe a father of many children and grandchildren, but he is like the number one person. So for whatever reason, and I don't know who started with this, so the godfather of AI, that's what Jeff Hinton has been called, and I don't know who started with it. He left Google last week.
Yeah.
And at the same time, because, he feels like, well, I feel that, he steps away from the technology which he helped develop. And for my feeling, it's like water on the mills of those that say we should pause AI development. I'm not, for the moment, going to take a left or right. I'll talk to that later. He gets support, or the other way around. He actually supports Gary Marcus, which I believe we may have in a couple of weeks, months.
A couple of weeks, yeah.
And it was a private email published by Gary. And now my feeling is that I would say it's his decision. I'm not sure that he's really thought it through, because my feeling is that now you have all the media, that he gets the complete media attention, like the godfather of AI says, AI is dangerous, or you should be scared, or whatever it is. And that's a little bit the shame. So then, of course, there was a journalist asking his, I would almost say, counter opponent, which is then Jürgen Schmidhuber. Yes. He was called the father of AI, as I just said, and he says the rise of artificial intelligence is inevitable, but it should not be feared. Now, he is today, as we know, and maybe we're going to talk to Jürgen again sometime soon. We have had him together with Sepp in our show. Today, he's a director of the King Abdullah University of Science, Technology, AI Initiative in Saudi Arabia. And he believes that AI will progress to the point where it will surpass human intelligence, and it will pay no attention to people. That's so interesting, right? They're going to be, that's people. What are they? He makes the relation to ants, right?
Yeah.
Of course, many people are very interested in ants, and if we say, look at these small creatures and how interested in they are. Now, anyway, Jürgen believes that we cannot stop the AI race, but then he also thinks that we should not stop it, He says in 90% of all cases, AI research is really about our old motto, which is making human lives longer and healthier and easier. And he says I will be much more worried about the old danger of nuclear bombs than about the new little dangers, he says, of AI. So my view, I guess, bottom line, I'm kind of in between Jürgen and Jeff.
Yes.
Those two have had long-running disputes, as some of you know, over appropriate credit for AI research. I believe, yes, we cannot stop it. It's the same thing as what Jeff did refer to. You know, when uranium was invented, immediately scientists from around the world realized the huge positive and negative power. Actually, I ordered a book this morning. I think it's called The Making of the Bomb. Mm-hmm. There was a reference in The Guardian. Seems to be a very, very interesting book on how these things, that was 1930s, I believe, this development. So, and Hinton, I must say, specifically refers to the International Atomic Energy Agency. We know it's in Vienna, I believe, right?
Vienna, yes.
They call themselves the world's Center for Cooperation in the Nuclear Field and seeks to promote the safe, secure, peaceful use of nuclear technologies. I would say, why not? And I would say, let's start, maybe finish the European AI Act as one. Make sure we allow friendly AI use, forbid unfriendly use, and limit potentially dangerous use.
I think that's an interesting idea, this IAEA in Vienna, to compare it to AI institution. That's really interesting, yeah.
Yeah, or the other one has been, I've been proposing the non-use of chemical weapons, right? It seems to be, do we hear every now and then? I mean, there's, I do not really like listening to the general news too much today, I must say. I do try to. I mean, I can't sit here and talk to you and talk to our listeners and be dumb, so to say, right? So I did hear about the coronation, but I forgot his name. What was his name of the new king?
Charles III.
Oh, it's Charles. There you go. So I am dumb. No, but the point being, there are so many negative things, and I'm going to write a letter to the local station that says, like, if I'm listening music, if I'm listening to a culture program, whatever I'm doing, it doesn't matter. Why does any program need to break every hour with news of the world? And all of us know that news is not always positive. Stop here, Peter.
Peter, please. We will cut this.
Sure, yeah, that's perfectly okay. So, but it was a very interesting contrast, I do believe. Two people who have had strong disagreements, maybe not always technically. It was more on the point of citation. One says, I'm not sure I really support that. It's almost the fact that Jeff kind of stepped away. It's almost making it worse than is my feeling. And on the other hand, there's a guy, Jürgen, who says, oh no, these AIs, they're not going to take care of us. We are so uninteresting for them.
Maybe Gary can convince you in the next weeks.
Let's see. Yeah, maybe. Yeah, so that's interesting. So he published this email where Jeff said, I agree with all of you, which he then wrote at that time.
I want to add something, because there's a discussion on Twitter going on about these godfathers and fathers, and this is pushed by young researchers and scientists, and they say, what does it mean, godfather and father and stuff like that? And there's a new generation of AI researchers, and they are coming now. And that's very interesting, because the older one is going out and now a new generation is coming. That's very interesting.
Okay. Yeah, that's very good. There was let me comment on that just directly, interactively, because there was a reaction here from Kalpana is her name. She was saying the same thing in this LinkedIn thing between the two guys. The point was never to be to bring up again this ongoing disagreement between Jürgen and Jeff. And I did then copy, and I read two sentences out of this, which then Jürgen wrote 3 years ago, right? He says, we must stop crediting the wrong people for inventions made by others. Like those who know me and can testify, finding and citing original sources of scientific technological innovations is important to me, whether they are mine or other people's. That goes on, I'll stop here. But he has always been almost to the point of I wouldn't call it neurotic, Jürgen. Please, if you hear this, forgive me. But he's so awfully, so very, very precise. And then he always comes back to say, we need to do this. And if that is the discussion that you're referring to, the young generation is building on top of, yeah, sure. Do we need to call certain people godfathers or not? Well, I think it's important that you go back to where there is a certain group of people that started things, and there's nothing wrong with, calling out their names, I believe. That is more important than not calling out and to do as if there was no foundation.
There's a shift in this whole scientific world, and because I think in the moment there's a big conference in Rwanda, the first time in Africa, the ICLR is in Rwanda, and you see also Africa is playing a bigger role in this topic, and there's a new generation of AI engineering scientists, researchers, and everybody is very, very impressed about Rwanda and about the conference. K. Snoop was there, and he told me that was one of the best conferences he ever led. And you can see there, when you go there and you see the people who are part of this conference, there are a lot more of people from Africa coming to Rwanda than they come to USA or when it's based in Europe. So we need to integrate also another culture, another whole continent in this AI discussion. I think it's very interesting times for AI research and AI topics. Yeah.
Very good.
Yeah. And I have one more technical news. I don't know if you read the article from Professor Marco Huber from Fraunhofer IPA. He shared a very interesting article. I will put it in the show notes. It's all about open source and AI, and the main conclusion: open source is eating Google and OpenAI for breakfast. Yeah,
that was another one. I forgot to write that down. There was I did refer to it in the, I believe, OPC Foundation podcast.
Yes.
There was a leaked document, was it? And, I'm not sure that we need to make an official disclaimer here. We're not saying anything against Google or anybody else. That is what we read from somewhere as a leaked document. And they were suggesting, whoever at Google was suggesting, we have no USP. I mean, the open source is going to eat us and, what did they say? Us and OpenAI.
Yeah.
I believe specifically they said they're going to eat us for breakfast, right?
Yeah. I will put the article in the show notes. Everybody can read it.
And that's what we see happening, right? I mean, was it yesterday, the day before? There was one or two huge open source large language models, which are in specific areas so much better even than. And it's almost like I don't know all of the names anymore. We should probably keep our eyes open, Robert, and see that we're going to get a person who's maybe from the open source community to tell us what is...
You are always very skeptical about open source, and now you want to have an interview in the open source community? Peter.
Well, I'm not skeptical.
Times are changing, also in Neubiberg. Yeah.
I need to understand it.
Yeah, okay.
Yeah, sure.
Yeah.
Well, then let me do it if you want to.
You will do it, yeah.
And if it's good, you can use it for the open source podcast as well.
Absolutely. But
oh no, sure. We need to be okay. Maybe as one finishing thought from my side, sure. I am very much aware that OpenAI started out as OpenAI, and people are questioning if they're still open now. Sam, what's his family name? In interviews, he will always say that they're still OpenAI. They will not. Microsoft is not taking influence. And many people, of course, will not believe that or disagree that. So, if there is so many developments in this thing called open source, also with regards to large language models, we need to look at them. You or I.
Absolutely. But before we do an interview with the open source community, we have this very interesting interview about transformers, Hopfield networks, and the future of transformers with Günter Klambauer. It was a pleasure to talk to Günter again. Thank you, Peter. It was a pleasure to talk to you. See you next time.
Thank you, Robert. Have a good day. And also our listeners, enjoy your time. Bye-bye.
Bye-bye. It's a pleasure to talk to Günter Klambauer in Vienna. Hello, Günter.
Thanks, Robert. Thanks for inviting me the second time. Always a pleasure to talk with you.
So the first time was okay for you. Now
I'm back.
Yeah, you're back. We want to talk a little bit about large language models, and then we want to talk about the future of transformers and about new architectures. Every week a new large language model comes onto the market. What do you think? When will be the experience saturation of this topic?
Yeah, they have been very prominent, and actually they are around since 2017 with the invention of the transformer on which they are all based. And there were, of course, a bit of algorithmic improvements, but it's mostly scaling. So people train them, simply train larger models with more parameters, more layers, train them on bigger data sets. They include human feedback, which means that the output, so when the large language model produces something, that human gives direct feedback whether he or she like the answer or not, and the model can then improve. So the basic thing is still the same, and the different research groups, the big ones like the IT giants that can afford now to train a large language model, they basically rely on scaling, so on upscaling, bigger compute, bigger training data sets, more effort to tune the models and tune the output of the models. And this is the current trend. And I think we are seeing the peak now.
So there is a saturation?
I think there is a saturation. We are beyond scaling laws. So making a double as large language model now doesn't help as much as it helped a year ago. So this is beyond the scaling laws now. It doesn't help to just scale them. We need to have new ideas at this point.
What kind of new ideas?
Yeah, for example, one of the big ideas is to give them memory. So currently what they call context, or the old text prompt, is used as a kind of memory, but to connect them with real associative memory of things that happened in the past and this could also be knowledge, like knowledge from knowledge graphs and so on. So to have a memory-based architecture in the background, and the large language model interacts with that. So this is one trend that we're already seeing a bit.
Where we can see that.
There are, for example, approaches like read-through that retrieve from, so you have a database of text parts, and the large language model learns to retrieve certain text parts and put them together. So this is one of the trends. Then this data set of text from which it retrieves, we call it tokens. So that's the text parts. This is a kind of retrieval system, and this also works very well and could be considered as a type of memory. So we see the trend already, and I think we will see also, besides trying to include memory, we will see also algorithmic changes. So how this is trained. Currently, the methods are trained in so-called autoregressive fashion. Autoregressive means that you look at the sentence that you generated and just predict the next word. What is the most likely next word? Then you add this word, and then you look at the sentence again and predict the next word. Now, one of the IT gurus, Jan LeCun, already said, nobody will use autoregressive models in 5 years. There are other methods like diffusions coming up. They only work for continuous data. That means images, when you generate images with a stable diffusion and so on. So these are the diffusion models. But they might also make their way into the generating text. So we will see different types of algorithms and different so-called generative models, deep generative models, replacing the large language models in the next years.
With deep generative models, you mean you added memory, right?
Not only added memory, so there are completely different types of training algorithms. So not train them by predicting the next word, but training them from, for example, denoising, start from complete noise, and slowly by looking all at the words. So this is more like you would draft an image. You make a couple of pencil strokes, then you look at it, you change something, you look at the whole image again, you change something. And this is always looking at a whole text, making small changes here and there to overall improve it. This is a different way how to approach the problem.
And you mentioned to add a memory to a large language model. That sounds very easy, but it's not very easy. What is so difficult to add a memory?
Yeah, it's of course in computer science, we have different types of memories. In machine learning, you have to design also the memory, and you have to, since this is all learned, and the memory is something static that is not designed to be learned, you have to think about how to learn it. One option is so-called modern hop networks, where you have your entries. Think about like text documents, like you have a set of newspaper articles, and you don't know how to retrieve them, but you learn. So you try to learn a mapping into a space, so just couldn't be just a linear mapping into a high-dimensional space. And also the large language model learns a similar mapping to the same space. And then in this space, the relevant text documents that you need are similar, and you retrieve the most similar ones. So in contrast, what does that mean? For example, now when you interact with ChatGPT and you ask, can you write an article about, I don't know, French Revolution? Then it gives you something, but it doesn't give you references because it just, all the text is coded in the parameters. But this new type with the modern Hopfield networks, it would generate the text. It could be similar, but could also say, to generate this text, I have retrieved from the memory from text document A, D, and XYZ. So this would give you additionally the sources from which it has retrieved the information. And this will already be quite a good improvement.
Do you work on this topic?
Yes, we work on, so we were actually the inventors of these modern Hopfield networks. There were some trends so the original Hopfield networks date back to the early 80s, but they were discrete. And then there were some steps towards making them continuous. And we were the ones to change them such that they can build in deep learning architectures. We made them continuous and differentiable, and they can now be built in these deep neural network architectures. And we already had quite some successes, not for training, because we're an academic institution. We simply cannot train on this large scale. We don't have the compute. So we have used these modern Hopfield networks, for example, in chemistry to predict chemical reactions. So you have a database basically of chemical reactions that have already been done and documented by humanity. And you learn to retrieve, you look at a molecule, and then you learn to retrieve the correct chemical reaction and you apply it. So there it was tremendously successful, and also some other applications in areas that are not as data and compute intensive as natural language processing.
But your group is not the only one who works at this topic, adding memory to the large language model.
Certainly not. So there have been, so I've mentioned already the read-through architecture. I believe it's, I would have to look it up now. My memory is now bad. I think it's from Google Group. And this is one where they have a database of 1 trillion tokens from which you retrieve with a similar mechanism. Yes, there are also others, of course, working. There's also work trying to connect the language models to knowledge graphs. Again, yeah, so there is work in that direction, and I think this will change.
But everybody is focused on this large language model. Is there anything else the research can do?
Yeah, I mean, this is, I think from the public perspective and from your perspective, this is dominating. I think there are other trends that now are hidden behind the large language model. So we still have very good image generation that has improved a lot. And then there is another big trend, which is the physics. So it's currently deep learning is also considered now a disruptive technique in physics. And people use, for example, graph neural networks to solve partial differential equations and so on. So there is a big trend that was a bit more prominent before, but now is hidden by all the news about the large language models.
Can you go into a little bit detail to the hidden champions of AI, or what is the idea?
So the background is that these physics simulations are also very compute intensive. For example, for particles, you would model, you have a set of particles that interact, and you would model the physical rules guiding that, like interaction forces, impulses, and so on. But this simulations and also observations, if you really do it in a lab and track all the particles, you can also learn this with a graph neural network. So graph neural networks, they have the nodes would represent, for example, particles in a physical system, and you would learn how they interact. And this can strongly speed up magnitudes because you can replace the simulation with a quick neural network. Also, what you can do is coarse graining, meaning that you don't need the full resolution, a very fine-grained mesh, but it's sufficient to use a very coarse-grained mesh and still get the same accuracy for the results. And there's a huge trend. Also, one of my colleagues, Johannes Brandstetter, who is now at Amsterdam, is working on that, and Max Welling, and there are several groups working on those physics-based machine learning or physics-inspired machine learning. And they have a lot of successes modeling different types of dynamics, particle flows, fluid flows, molecular dynamics, so how molecules behave.
That's very interesting also for industrial use cases, I think.
Certainly, yes, of course. Also, designing new materials, designing new molecules can be done with such physical simulations and machine learning improvements of that. Indeed, yes.
Absolutely. I want to talk a little bit more about transformers, because there are some voices that are already saying, transformers, maybe they're just at their peak. How do you see that?
Yes, I think also the transformers, they have now entered all important domains and shown also there is so-called vision transformers that are used for computer vision. So it has been a kind of also unifying trend in machine learning that in the different domains, all of the domains can use the same basic architecture, which is a transformer architecture, and it's very powerful now. But now people see more also that now that we have reached this level, people see that they have some problems like the quadratic scaling. So it means, for example, for the case of pixels or words, it would be the transformer has a so-called attention mechanism. So each pixel would look at all other pixels to update itself. And this means you're quadratic in pixels or you're quadratic in words, which prohibits further developments. And therefore, people are now looking again towards other architectures. And we see a kind of revival of so-called recurrent neural networks in a different form, of course, improved also with attention mechanisms, which sequentially go through a text. It's more like you now hear me, you also hear one word after the other and are able to grasp my what I'm saying, but you don't have to compare and look back at all the words exactly that I said before again. So also in our brain, it somehow works sequentially, and this is what the RNNs are doing. So this RNNs would solve this quadratic problem, but are in their old form, like the long short-term memory recurrent networks that was discovered by Sepp Hochreiter before. In the original form, they're insufficient. So we have to find a kind of amalgamation of these two technologies and recurrent neural networks and attention mechanisms as they are present in the transformers. So I think this is the way to go.
Are you surprised that this is coming back?
No, I'm always in favor of the return of the RNNs. No, I like them conceptually, and I think they have a lot of analogies. Our brain processes information for conversation, but I mean, that should not be the only reason. It's also it's particularly appealing that they kind of can code a sentence into a vector, which says this is the thought behind the sentence that I said. So I think they have some very cool properties, and they should, I think we should try to work on them as basic architecture and try to get them up to the level of transformers.
What are the main advantages? What do you think?
The main advantages of the RNNs would be that they solve this quadratic problem. So they don't have to look at all words that have been said before again. And so they would be much faster and scalable in that regard.
And less energy consumption?
Less energy consumption, of course.
That's a topic we do not discuss in the moment.
So to train, I think for GPT-3, old generation of transformer-based large language models, it was still mentioned that they were trained for 300 GPU years. And if you factor, so a GPU runs at roughly 300 watt. So 3 GPU hours is roughly 1 kilowatt, and people know that this is expensive now. So you can calculate that it costs a tremendous sum only to train a single large language model. During development, you have to test different versions. You might train, the IT giants might train 100 versions of large language models before within attempts that fail. So it's a huge amount of GPU consumption and energy consumption that is used for the large language models, and therefore we need alternatives that are more energy efficient. Yes, very good question.
I think it's also interesting for the industrial sector, right?
Indeed, yes.
Because this topic is very, very important for them.
Yes, in industry, I think it depends on which industry, but also efficiency usually plays a role, energy efficiency especially.
When we talk to these large language model fans, or they say, oh, we can scale it very easily and it will run on the edge next to the machine. Is it really that easy?
If the edge device makes requests to server. No, I don't think you can. So a large language model, I mean, there are techniques like pruning and so on to make them smaller, but only to deploy it, they're quite big in terms of parameters. And the compute has to be done on the GPU. So for otherwise you have incredibly large inference times. You have to wait for minutes for the sentence to be generated. So I don't know which edge device.
But you can shrink it a little bit right there.
You could shrink the large language model a bit, but still the inference. So this means to get to predict it, because you have to, again, the autoregressive thing is now hampering you. For each new word you look at, and the quadratic thing, you look at all the old words and predict a single word, and then you do the whole stuff again. So if you generate a whole sentence or a chunk of words in one go, this would be much better already. So I think on edge devices, let's say it in that way, it's extremely challenging to put a large language model on an edge device.
But you can use these plugins or something, right? In the connection to a cloud infrastructure, I think.
In that sense, it works. Yeah, that would be, if you make requests, of course, then it works. Yeah.
What is on your research agenda, Günter, the next couple of months?
Yeah, so I'm very happy to announce that just this morning I woke up to a paper acceptance. So we got accepted a paper where we were able to use activity prediction models. These are models that predict molecular properties, and we were able to connect them or to steer them with human language. So it has something to do with large language models. So to tell, okay, you now have to predict a new type of biologic activity, and then the model can adjust. And this is a very cool model that one of my PhD students developed. And the downside of things is that I have to send him to Hawaii now, because the conference will take place in Hawaii in summer.
Yeah, that's pretty nice.
And now there's a big conference deadline ahead, mid-May, which is the NeurIPS, and we're working on several new things. One of the things is to use diffusions for discrete data, which would be related to what I said before, to replace, but we're not there to replace large language models currently. So these are more prototypical ideas. Diffusion models for categorical data, and also improving applications, so several applications in molecular biology and chemistry using contrastive learning on that side. Yes, so it's great to work in this exciting and thriving area.
But everybody asks you the question about this large language model. Isn't that boring for you?
Actually, I like this a lot, because you ask the technical stuff. People usually ask me only, how should we regulate them? Okay. What's the impact? What's the dangers, and so on?
How can we regulate that?
Actually, about you're the first one to ask me about the technical part, and this is what I love about talking about the large language model.
Oh, that's very, very kind of you. Yeah, thank you very much. So now, last question, how to regulate large language models?
Yes. So I think it comes also down to data use and data protection. So of course, we have them now. They are offered by a company, and
a lot of companies.
Think about also what you can do. So we are judging them also a bit hard, because we are able to extract information, how to maybe do something bad, or I don't know. But also if you Google something, how kind of make a bad thing at a device that is very dangerous, you would also by Googling find something. So first of all, we should compare against the search engines that we already have, and have similar regulation for what they give, because conceptually it's similar. You enter a text prompt and you get text back, so their regulation should apply. And the other thing, we should regulate them by the data usage. So is it allowed, on which they are trained? So they should be open on what they are trained.
Yeah, there's a discussion that I think Elon Musk wrote that, I don't know if it's right, but they use Twitter data or something to train this model, and now he's not very happy with that.
Yeah, you could also, for example, if you would train, there are a lot of problems with IT giants training models, because they have access maybe to your private messages. Microsoft has all the private GitHub repos. It could train on that, and somebody with inference could get that. So I think it's very important that the models, when they're developed, that the training data, so the text on which it was trained, is clear and released. And what would also regulation would help is if the model is offered as a service, that there's also an open source release of the model, maybe with some regulations that people can check what the model has learned. And also debiasing would then be possible. So to people to research on the model weights and the model parameters. And for example, if you find there are techniques out to remove biases, gender biases, for example, that the large language models have, you would be able to adjust these weights or parameters such that there is less bias into it. So there's a tremendous amount of work. And if the models were open, we could improve on that.
What do you think about this German company Aleph Alpha? It's a German large language model based in Europe, open, and you can look into the model. Based in Heidelberg, and it's I think the new rising star in this topic.
That's super, yeah. That's a great effort, and I think it helps the community.
But they are focused on B2B. That's interesting.
B2B. Yeah,
they're absolutely focused on B2B, because they said theirs must be trustworthy and like this.
No, that's a super trend. There's also other trends like the Leon initiative that tries to open source this. And I think this is the way to go. One word about regulation. I cannot give you a good solution because there is, since 2 years, I know that some of my colleagues in the Alice network, they are trying to come up with good regulations with the EU and working 2 years on that. And it's very hard to find solutions. And so I gave a couple of ideas that I have, but overall it's an extremely hard problem how to come up with regulating AI models. So, and a lot of very smart people are currently thinking about that and have a hard time to come up with solutions. So it's a good question, but it's extremely difficult to answer. Yeah. Yes.
Günter, it was a pleasure to talk to you. Greetings to Vienna.
Yeah, greetings to you too. And Robert, hope to hear you very soon again.